Hi friends, today let's learn about arrays in Java. As you advance in programming, efficient memory management becomes essential. Let's analyze a situation. If you want to store the marks of 5 students of your class in the computer memory, what will you do? You will declare 5 different variables. For example, int m1, m2, m3, m4 and m5. Now, let's see the memory allocation for these variables. As you have declared these 5 variables as independent variables, Java compiler or interpreter will consider them as unrelated and scattered memory will be allocated for them. Continuous memory locations will not be allocated for these variables. As continuous memory locations are not allocated for these variables, it takes more processing time to process these kinds of data values. Assume that if the number of students increases to 100, you have to declare 100 different variables and use 100 assignment statements to assign values. As the data size increases, it's not practical to declare too many variables in the memory. It increases the complexity of your program. Your processor takes more processing time to process the data as they are stored in a scattered manner. To overcome all these difficulties, we can use arrays in Java. What's an array? An array is a container object in Java which can hold a number of data items of the same kind. It can be compared to a shoe rack which has many compartments to store the shoes in it. The entire shoe rack is known with a single name and each compartment has a unique number to identify it. Now, let's look at some examples of arrays in Java. The first one is an array of characters. The name of the array is X and it has 5 contiguous storage locations. Each storage location stores a single character and each storage location is uniquely numbered, starting from 0 to 1 less than the total number of storage locations of that array. As there are 5 storage locations, numbering starts from 0 and the last storage location has the number 4. These numbers are called as index numbers or subscripts of the array. Array name followed with the index number is used for accessing an element from the array. Now let's look at the next array. It's an array of integers named as y. This array also has 5 integer storage locations to hold 5 integer data values. And the index number starts from 0 and the last index is 1 less than the total number of storage locations of the array. That means the size of the array. Next one is an array of real numbers, that is floating point values. Array's name is M. It has 3 storage locations, 3 floating point storage locations. Each storage location is of 4 bytes. Array of floating point numbers. Each storage location will be able to hold a floating point value. The first storage location has the value 10.5, next one holds the value 20.6 and the third storage location holds the value 30.7. All the data items are of the same kind. As the last one is an array of strings which is named as C, which holds 3 countries' names. It has 3 storage locations. Now let's see how to access, how to refer a particular storage location of the array. To refer a particular storage location of the array or to access the elements of the array, we can use array name followed with the index number. To access the first element of the array named as x, x of 0. Array name followed with the index number or subscript is used. X of 0 is equal to, you can assign any value to that storage location. X of 0 is equal to j, the character j I have stored. So, instead of a, the character will be replaced with j. to access and print a particular character from the array, we can use system.out.println x of 1, x of 2, x of 3, x of 4, like this. So, an element of the array can be accessed by using array name followed with the index number. An array is called as a subscripted variable. In Java, you can arrange the data in rows or columns, or you can arrange the data even in the form of a matricular structure. Data arranged in rows or columns, a single row or column is known as a single dimensional array. Example, these are all the examples for single dimensional arrays. Now let's see an example for a two-dimensional array. The first one is an example for single dimensional array. It has only a single row. And the second one is an example for two-dimensional array. Here there are rows and columns. Rows are horizontal ones. Row 1, row 2 and row 3. There are 3 rows and 3 columns. Column 1, column 2, column 3. Each row is numbered, uniquely numbered, and each column is also uniquely numbered. An intersection of row and column is known as a cell. So here each cell can hold a data in it, and each cell is uniquely identified with a row number and column number. So the first cell is identified with a row number and column number m of 0, 0. The first cell is in first row and first column. So m of row number, column number. M of 0, 0 means that is the first data of the two-dimensional array named as m. M of row number, column number. So m of 0, 0 means it's a reference to the first cell of the two-dimensional array named as m. So how do we refer the second cell of this two-dimensional array? M of 0, 1. So 0, 0, 0, 1, and the last cell in the first row is identified with the index numbers 0, 2, which is in column 2, m of 0, 2. And the second row, all the cells of the second row are referred as, second row is numbered as 1. So m of 1, 0. It's in the first column. M of 1, 1. M of 1, 2. And here the last row of this particular matrix or the tabular structure is identified with the index numbers m of 2, 0. This is in the last row, which is numbered as 2 and in the first column. And the next cell is in the second row, which is numbered as 2 and column 1. So 2, 1, 2, 2. So array index starts from 0 and the last index will be 1 less than the size of the array in case of single dimensional array. When we consider two-dimensional array, how many rows are there in this array? There are 3 rows and 3 columns also. So array row number starts from 0 to 2 and column number starts from 0 to 2. So each cell in a two-dimensional array is uniquely identified with the array name followed with the row number and column number. Now let's discuss the different ways to create an array in Java. In Java, we can create arrays in 2 different ways. The first method is by using an assignment statement, and the second method is by using the new keyword. Now, let's learn to create a single dimensional array by using assignment statement. So, the syntax for creating a single dimensional array is type of the data. What kind of data you want to store in the array? Data type. Give a name for the array name, followed with a square bracket equal to. The values which you want to store in the array should be given as a list. Each value should be separated by comma. For example, you want to create an integer array named as n to store 3 integer values. So int n, data type is integer, name of the array is n, square bracket, which indicates that this is a single dimensional array, and 3 values are given in the parenthesis separated by comma. So an array of 3 storage locations will be created to store these values into the array. Next one is a character array. This character array contains 5 characters. So 5 character storage locations will be declared. Each character storage location will be of 2 bytes and total 10 bytes will be the size of this array. So these values will be stored in each storage location. Next one is an array of strings. S is equal to 3 strings are given in parentheses. So these 3 strings will get stored into the array named as S. Now let's look at the syntax for creating a two-dimensional array through an assignment statement. The syntax is data type, what kind of data you want to store in the array, followed with array name, and 2 square brackets should be given to indicate that there are rows and columns in the array. It's a two-dimensional array. And the value for each row should be given in separate group, in separate parentheses. Each group should be separated by comma. And each group should contain same number of values, as number of values in a group determines the number of columns that should be there in the two-dimensional array. So for example, an integer array int x, which is a two-dimensional array, as it is the array name is followed by 2 square brackets and the values are given in 3 groups. In each group there are 3 numbers. So the number of groups listed is 3. So there will be 3 rows. Each group represents the values for a single row. As there are 3 groups, there will be 3 rows in the two-dimensional array. And in each group there are 3 values. So each group has the same number of values. So there will be 3 columns in the two-dimensional array. So this command creates a two-dimensional array with the dimension 3 by 3, a matricular structure with order 3 by 3. And the next one is an example for a string array, two-dimensional string array. In this, 2 groups are given. So there will be 2 rows in the two-dimensional array. And each group has 3 strings. So there will be 3 columns in the two-dimensional array. The order of this matricular structure is 2 by 3, 2 rows and 3 columns. Now, let's look at the second method to create an array in Java by using new keyword. We are going to create single dimensional array by using new keyword. The syntax to create a single dimensional array is data type, array name, followed with a square bracket equal to new keyword, and the same data type we have to mention here, and the size, that is the dimension of the array. How many storage locations you need in your array, that is the size of the array you have to specify. For example, I want to create an integer array with 5 storage locations to store 5 integer values. So use the syntax int, data type is int, array name is x, it's a single dimensional array, as a single square bracket is given here. New keyword is used. New keyword allocates the memory for the array. New int of 5. So an integer array with the name x is created with 5 integer storage locations. Each storage location is uniquely numbered with the subscripts or index numbers. Array index starts from 0. The first index of the array is 0 and the last index of the array will be 1 less than the size of the array. In this case, an array is created with empty storage locations. Now we have to use the statements to assign values to this array. Either you can use single statements like x of 0 is equal to a value, x of 1 is equal to another value. Single assignment statements can be used to assign values to it. X of 0 is equal to say 10. So the storage location which is identified with the index number 0 in the array x. X of 0 refer to the first storage location of the array will be assigned with the value 10. X of 1 is equal to the next value, say 20. 20 is assigned here. X of 2 is equal to the third value. Third value is assigned in the third storage location. X of 3 is equal to next value is assigned here. X of 4 is equal to the last value. 50 is stored in the last storage location of the array. But using assignment statements to store data into these kinds of arrays, it's not practical as the size of the array increases. If you want to store 100 values in the array, it's not practical to declare 100 assignment statements like this. Instead of that, we can use a looping structure to accept the data into the array. Let us see how it can be done. For loop is the most suitable one to store the elements into the array. For loop index variable I starts with the first index. I is equal to 0. I less than the size of the array. I less than 5 plus I. The last index. Array index starts from 0 and the last index of the array is 4. So I takes the first value as 0 and the last value of I will be less than 5. That is 4 plus I. How the value of index variable increases, changes, increased by 1. 0, 1, 2, 3, 4. So plus I. And to store the data into these locations, we can use scanner class objects nextInt method. So x of I is equal to scanner class objects nextInt method. As we have used a loop here to store the values into this array, when the loop executes, the initial value of I will become 0. So x of 0 is equal to, user enters a value that will get stored in the first storage location. In the next iteration of the loop, the variable I, loop index variable I takes the next value 1. So the reference will become x of 1. X of 1 is equal to the next value entered by the user. X of 2 is equal to the next value, x of 3, x of 4, the last value entered by the user will get stored into this array. This is how a single dimensional array is created by using new keyword and assign values to the storage locations. To access the data from this array, suppose you want to find out the sum of all the elements of this array, we can use a looping structure. Each location is referred by array name followed with the index number. We can declare a sum variable, say sum is equal to 0 initially, and read each value from the array and assign it to sum, add it to sum. Sum is equal to sum plus x of I. So a loop can be used to process the data of the array. It will be more comfortable than using individual assignment statements and statements to access the values from the array. Now, let's look at the syntax to create a two-dimensional array by using new keyword. The syntax is data type array name followed with 2 square brackets and the keyword new which allocates the memory for the array, data type, new data type, how many rows you need in your array, the number of rows and the number of columns should be specified. For example, I want to create an integer array with 2 rows and 3 columns. So the syntax is int. Data type is int, array name is x, it has rows and columns, double subscripted variable, new keyword is used. Integer storage location should be reserved, new int of 2 by 3, 2 rows and 3 columns. So a two-dimensional array, a matricular structure like this will be reserved in the memory for storing the data. So it has 2 rows and 3 columns. Rows are numbered as 0 and 1. Columns are numbered as 0, 1, 2. To assign the data to these storage locations, the first cell is identified by x of 0, 0. Address is 0, 0 and the second storage location is 0, 1 as it is in the first row. The next storage location of the first row is identified by the index number x of 0, 2. And the last row cell addresses are 1, 0, row number, column number, 1, 1, 1, 2. These are the references of these cells of this particular array. So to assign values to these locations, you can use individual assignment statements, or to access the data from these cells, you can use individual references like this. X of 0, 0 is equal to a value. So x of 0, 0 is the first storage location of the array. The value 10 gets stored here. X of refers to the second cell in the first row. X of 0, 1 is equal to 20. X of 0, 2 is equal to the next value, 30. Now, when you look at, you can see that row number, when you store the data into the first row number is same, but column number changes. 0, 0, 0, 1, 0, 2. So, we can use a nested loop to assign the data into the two-dimensional array. Now, to store the data into the second row of this array, we can use the syntax. Second row is identified by the index number 1. X of 1, 0 is equal to a new value. Say 40, x of 1, 0 is equal to 40, and x of 1, 1, 1, 1 is equal to another value, say 50 is assigned there. So 50 is stored here. X of 1, 2 is the last storage location of this array, is equal to 60. So the value 60 gets stored here. This method of assigning values to a two-dimensional array is not practical as the size of the array increases. We have to use a nested loop for assigning values to a two-dimensional array. This we can discuss later in the coming videos. For more updates and videos, like, share and subscribe my channel.